Welcome again to the Lion Sunday Speaker Series. This is number 3 in our program. Welcome also to those on Zoom, and of course to our speaker, Malcolm McAdie, Doctor of Veterinary Medicine. It's with great appreciation that we, the residents of Protection Island, acknowledge this land as the unceded territory of the Snuneymuxw First Nation and of their legacy throughout the land. Thanks to Emily for chairs and Zoom setup. Talking about donations now. Last week, our donations went to the PINA, and this week they will go to the Marmot Recovery Foundation. This talk is being recorded for future listening, so Emily will let us know on ProWow when that's available in a few days. Questions, please, at the end of the talk. Zoomers, use the chat box or raise your hand so Emily can see it, and please mute yourself otherwise. Now, I would like to introduce our speaker, Dr. Malcolm McAdie. Malcolm was born in Calgary, grew up in Edmonton or close to Edmonton, and as a teen, he worked in the Alberta game farm, where he helped look after, for example, gorillas, tigers, and camels. And he realized then that that was how he wanted to spend his life, managing wildlife and caring for them. He achieved his Doctor of Veterinary Medicine at the Western College of Veterinary Medicine in Saskatoon. And he's also a master's degree in environmental science from Thompson Rivers University in Kamloops. Malcolm did 7 years in private practice and then moved to Vancouver Island, where he's worked for the Wildlife Center in Arrington, the Marmot Recovery Foundation, and his own, the McAdie Wildlife Veterinary Services. He's cared, for example, snakes, wolverines, otters, bears, possums, fishers, loons, and marmots. And just a tiny bit about that. The Vancouver Island marmot is native to the mountains of central Vancouver Island, and beginning in the late 1980s and throughout the 90s, populations of this rare endemic mammal declined precipitously. By 2003, the number of wild marmots was below 30, and the species was spiraling towards extinction. Malcolm will tell us what's been happening in the intervening years and where the marmot recovery efforts stand at this point. He's married and to a vet, actually, and lives in town. They have 3 children, all of whom are on their own now. Please welcome Malcolm McAdie.
Thank
you.
Well, thank you very much for allowing me to speak today, especially on Super Bowl Sunday. I have it under good authority that Taylor did make it into the country to watch, so in case anybody's worried about that. So, for me, getting to work over my career has been an adventure at times. So yeah, so it's certainly been an adventure, and during the course of my career, I've been able to work at sites all across British Columbia and Alberta and in Canada. So, you know, I've worked at places like Triangle Island off the west coast of Vancouver Island. I've worked in the Canadian High Arctic as well, the Olympic Peninsula in Washington State, the Copper River Delta in Alaska. One of my favorite places, Prince William Sound. That's actually Yellowstone National Park. Bahia San Quintin in Mexico. Southern Denmark. I didn't have any good pictures, so we did all the work at night, so sorry about that. And actually, just over a year ago, I was in Hokkaido, Japan, doing some work as well. And so getting to work is an adventure. And then when I actually get to work, I've been able to work on all sorts of weird and wonderful critters. And so today I'm going to talk about one of the critters that has occupied a great deal of my attention over the last 30 years, the Vancouver Island marmot. So the title of my talk, Ecology and Conservation of the Vancouver Island marmot. So what I'm going to talk about, first, I'll give a description of the species, its life history and biology. I'll talk about the decline of the species and our recovery efforts. and then updates you on the current status of this critically endangered species. So, description, life history, and biology. So just as sort of, actually at the top there, it's you can't see it, but this is sort of marmots 101. So just sort of the basics. So marmots are rodents, so members of the order Rodentia. And so out of 4,000 total mammal species, rodents account for about 1,500 species worldwide. And the second most number of species are represented by bats. So just sort of little piece of trivia there. Rodents range from the pygmy jerboa, which weighs less than a quarter, really, to the capybara, which is about 200 pounds. So it's quite a significant size range. So rodents, the term is derived from to gnaw or corrode, and rodents are characterized by this continually erupting incisor. So they're, we all know, like rodents, their teeth will grow throughout their lifetime. And the chisel so the tip of their incisors is actually created by the difference in wear between the harder enamel and the softer dentine. They don't have any canines, and that area between the incisors and the premolars is known as the diastema. Just another sort of rodent trivia. So you can see that the Vancouver Island marmot have white incisors, and that's because a large part of the enamel is actually within its supporting stroma has magnesium. And then you look at these bad boys. So that's actually a nutria on the upper left and a beaver. And so their enamel actually has a high iron content, which makes them much stronger. So, when you see that, it's because, they really need teeth for, like obviously chewing on wood and all sorts of different activities. So marmots are members of the squirrel family. And I guess if you think about it, they really think of them as large ground squirrels, most closely related to prairie dogs and ground squirrels. And so marmots are actually the largest members of the ground squirrels. They have this typical physique, so they've got a very stout head, short neck, stocky body, a large abdomen, powerful legs for digging, and a bushy tail. And there's about 15 species of marmots worldwide. I say 15 plus there because there actually is the possibility of a new species being described in the Cascade Mountains. So that's sort of based on some recent genetic work. So the jury's still out on that. And the 15 species are found all in the Northern Hemisphere, so in North America and Eurasia. And the term marmot is actually derived from, I don't know if anybody knows their Latin, they could call me out on this, I don't really know, but Murum montis, which means mountain mouse. So just another marmot factoid. And so we call a group of crows a murder. We call a group of eagles a convocation. I didn't know this one. A group of wombats is a wisdom of wombats. And so what unless anybody has the answer right now, I'll tell you later in the presentation. Does anybody know what we call a group of marmots? No, it's actually, I'm not sure who comes up with that stuff, but I found it kind of surprising. So I guess that'll be the teaser, so you'll stay to the end. So there's 6 species of marmots in North America. There's 2 that are exclusively American. So the Browers or the Alaskan marmot, which is found up in the Brooks Range in northern Alaska. The Olympic marmot, which is an endemic to the Olympic Peninsula. So you go across the Strait of Juan de Fuca, and that's where you'll find this particular species. They are closely related to the Vancouver Island marmot. And then 4 of the 6 species are found in British Columbia. So this includes the woodchuck or the groundhog. It's distinct from the other marmot species in that it's a lowland species. It's more solitary, but you can see that it got quite an extensive range across North America, and they're actually have shown movements up into Alaska, up to the Yukon River, and it's possible that they're actually following the highway even further north. So quite a successful species. In the interior of British Columbia, we'll see the yellow-bellied marmot. In the mountains, we'll see the hoary marmot, which is also closely related to the Vancouver Island marmot. And of course, the topic of today's presentation, Marmota vancouverensis. And I should say it's endemic to Vancouver Island, it's endemic to Canada, and Canada really only has five, depends on which taxonomist you talk to, 5 endemic mammal species. So the Gaspé or long-tailed shrew, the maritime shrew, and then 3 species of collared lemmings. And there they are. So Vancouver Island marmots are chocolate brown to black with these really attractive white accents on the nose, the forehead, the chest. People see pictures of them, they don't really appreciate what their size is necessarily, but we always equate them to the size of a well-fed house cat as adults. The males are bigger than the females. They're social, so they live in small family groups or small colonies. And they're fossorial, so they live in burrows. So burrows are really an important part of their lives. They're slow to mature, so they reach maturity at about 3 to 4 years of age. They exhibit, typically in the wild, reproductive skipping, so they only produce a litter every 2 to 3 years. The average litter size is 3 to 4. We've seen litters up to 6 in the wild, and in captivity, we've actually had a couple times where the females produce a litter of 9. But overall, because they're late maturing, they have reproductive skipping, they have a low lifetime reproductive performance. So as we sit here right now, the marmots are in hibernation. So they're true obligate hibernators, and they hibernate in small groups between October and late April. And during that time, that 6.5, 7 months, they subsist entirely on their fat reserves, so they don't eat. And this is actually just a graph of some of the work that I was involved with on hoary marmots up in Alaska. So these hoary marmots actually had implanted temperature loggers. And so we're actually able to see what their body temperature was during the course of hibernation. And so you can sort of see there's a pattern there. And at the lowest point, their body temperature was 2.5 degrees. And then there's this cycling every 2 to 3 weeks of them approaching what we consider to be a normal active temperature of 38 degrees. The interesting thing is that's not just one animal, that's a group of animals. So they all get cold together and then they all warm up together. So it's quite synchronous. And even though they spend 80% of their time in torpor where they're cold, it's very energy efficient, they exhaust 80% of their energy reserves warming up. So they'll warm up for 24 hours and then they'll cool down. So quite an amazing process. I mean, I've worked on these marmots for all these years and I just find it just incredible.
Bottom scale in days.
Yeah. So and so the 0 would actually be, obviously the time that they were implanted, not the calendar. Yeah.
So is that normal hibernation pattern?
Yeah.
For other animals?
It really depends. Like, so these are true hibernators. So, their body temperature goes down, quite profoundly, whereas bears are not considered to be true hibernators. So their body temperature only goes down a few degrees. They're more easily aroused. But yeah, this is a pattern actually, like reptiles don't do this, because they go through brumation and not hibernation. So they remain cold based on their ambient conditions. But yeah, this is pretty normal for a lot of species. And so why do they warm up? And the interesting thing is, if you have a marmot in torpor where it's cold, its body temperature, or sorry, it doesn't exhibit any brain waves at all. But during those warming cycles, the predominant brain waves are actually comparable to REM sleep. So it's like they have to have these arousal periods in order to reconstitute tissues, including brain tissue. So yeah, quite an amazing thing. But I guess you could say that marmots really are kind of amateurs in a way. Arctic ground squirrels, they also hibernate for 7 months, subsisting entirely on their fat reserves, and they super cool their bodies using like glycoproteins or antifreeze. Parts of their body are actually like below freezing, so 2.9 degrees. So pretty amazing process for sure. And then in late April or early May, the Vancouver Island marmots emerge from hibernation. So the marmots are in a burrow. They plug the burrow with dirt and rocks and feces, and then there's several meters of snow on top of that. So it's a very stable, thermally stable environment. How do they know when to wake up? They say that they've got this sort of intrinsic circannual rhythm or this internal clock, but that what that actually is, I don't think anybody really knows for certain. No, so most of their fluids will be the result of just catabolism of fat. So their fluid reserve requirements are pretty minimal. So you think after 6 to 7 months of not eating, they would be ravenous, but it actually takes a while for their appetites to kick start following hibernation. And the first priority when they come out of hibernation is to breed. And then after a gestation period of about 32 days, they give birth to their young. And like a lot of rodent species, the young are, blind, pink, very undeveloped.
So are they before they hibernate?
Nope. So they come out of hibernation, and within days, like their breeding opportunity is only like a few days out of the year. So that's the first thing they do as soon as they come out of hibernation. Whereas other species, like for example, bears will breed in the spring or summer, mostly the summer, but they have delayed implantation. So the fertilized egg will just sort of float around in the uterus, and then a couple months before they give birth, it'll just implant. But these guys, no, they breed, and then it's a very kind of rapid kind of life history that they have. And so the young grow very rapidly. We like sort of like little weeds almost. And so within about 4 weeks, they're weaned and they're transitioning to solid food. And it's kind of neat, like so mom is starting to cut them off the milk. And it's that hunger which is thought to motivate them to come above ground. And you see these little clusters of these guys, and you can sort of tell like they're at the natal burrow where they were born, and they're scared of their own shadows. It's really kind of funny, but they become bolder and bolder, and they come out and they start nibbling and trying all the different foods that are available to them, and they transition from a milk diet to solid food amazingly quickly. And they become bolder and bolder, and pretty soon they're all over the colony site. But this is a good time to sort of get a count on them because they're all kind of clustered, and any sort of motion or movement or shadow, and they run back inside. And then once those young are weaned, and that happens in late June or early July, the adults, the pups, all the marmots have an opportunity to put on weight in preparation for the following hibernation. And they when you look at the females, so she goes through hibernation, she goes through breeding, so she goes through gestation, lactation. Gestation, lactation also require a lot of energy. And it's really only after she weans those pups that she's able to put on enough weight to get her through the following year. And so, when you think about like 2 months a year where she's able to sort of make hay while the sun shines, it's kind of understandable why they in the wild they actually have this reproductive skipping, because the energetics of producing a litter are such that for her to do it in successive years is really a challenge for her. So they're herbivorous, so they eat plant food. They have a single chambered stomach. They have a very well developed hind gut. So their cecum and their large intestine is quite voluminous, and it's used for processing all this plant material that they take in. People ask what they eat, and they've actually documented that they eat at least 50 different types of plants. So it's very complex because those plant species change over the course of the summer, and they selectively eat certain parts of plants as well. So their nutrition, and we were trying to get on top of it, but it's really sort of a complicated kind of thing to understand. In the spring, the emergent grasses and sedges, start to peek out through the melted areas. So that's what they start feeding on. And then flowers in summer. So these alpine flower blooms are really where they put on most of their weight for the year. And they have because of that hibernation, because of this abundance of food in the summer, they have this profound seasonal variation in their weight. And the changes between their weight, can vary between 30 and 50%. So between the time they come out of hibernation and the time they go back into hibernation, that's how much their weight can change. So they're very geared towards taking in large quantities of foods and converting it to fat in a very short period of time. Oh, and I should say, the image on the left is just a marmot that came out of hibernation, and you can see just how emaciated she is. And we actually thought that's Wascana. We actually thought that she passed away. And when we walked up to her, we realized that she'd gone back into torpor. We brought her back into captivity, and she was able to put on weight and get released. Like it's amazing how far their bodies can drop, how much they can lose of their fat and even some of their muscle tissue and still rebound from it. So marmot habitat. So these steeply sloped south to southwest to west facing subalpine meadows. It's where they live, between 900 and 1500 meters elevation. The trees in those areas are inhibited by avalanches and snow movement. The marmots require deep soil for constructing their burrows, and they also require elevated rock complexes for thermoregulation, for watching for predators, et cetera, et cetera. So those are all the components that you'd see where marmots live. And this type of optimal habitat is actually very sparse and patchy on Vancouver Island. So their range, now the range of the Vancouver Island marmot has expanded and contracted in association with millennia of glaciation and warming. But it was first described to science in about 1910. And so within that historical time period between 1910 and the first scientific studies that went on in the 1970s, the range extended from the mountains to just to the immediate north of Lake Cowichan up to about Mount Shone. And that's a linear distance of about 200 kilometers. So this species has limited habitat and a very restricted range, and these two equate to intrinsically low numbers. So this species was declared to be endangered back in 1978. So now decline in recovery efforts. So beginning in the late 1980s and throughout the 1990s, this rare species started to show precipitous and steady declines. And in fact, we actually got to the lowest point in 2003. At that point, at the end of the field season, we only knew of 22 wild marmots. So that's how low they had become. From that historical range, it had shrunk down so that we had maybe 4 or 5 colonies in the Nanaimo Lakes area, as indicated by the blue circle. and then this solitary colony on the ski hills up at Mount Washington. So why did they decline? Well, if you look at what sort of landscape the marmots originally lived in, it was these small subalpine meadows surrounded by old growth forest. And that landscape underwent very extreme changes. So if you look at, by the time we got to year 2000, it was really, these natural meadows were mostly intact, surrounded by huge areas of logged habitat. So, very dramatic landscape change. So rather than moving from one natural meadow to another, the dispersing marmots were attracted to these transient or ephemeral logged habitats. So they'd established themselves there. So this disrupted the genetic exchange that occurred between the colonies, and it interrupted the natural mechanism that allowed for the support of all these colonies. So it led to a downfall of the meta population. And at one point, over 50% of the wild population actually had transitioned to these logged areas. The problem is, they'd be in these log areas, they would thrive for a period of time, the colony would thrive, but then like Vancouver Island is a very good place for trees to grow. And so you get this sort of sad sort of state where the marmots would stay within the logged habitat, but it would change or transition to, it's like a grove of Christmas trees, which was unsuitable habitat for long-term maintenance of the colony. Plus, it also increased them to predation pressure from cougars. So those trees allowed for stalking cover. So the cougars could actually get closer to the marmots and have more success. In the logged habitats, the marmots' favorite place to build their burrows was actually along the deactivated roads. And those were also travel corridors for wolves. And at the same time, there was also this decline in black-tailed deer. So at least for a short period of time, wolves and cougars probably put more predation pressure on the marmots because their normal food source, the black-tailed deer, were in decline. The open habitat also facilitated an expansion in golden eagle numbers as well. And I'm not sure I believe this or not, but it's sort of been speculated that the introduced eastern cottontail provided sort of an additional prey base that supported the golden eagles. And also, when you look in Strathcona Park, like the fact that it was sort of bisected by Buttle Lake, that probably interrupted movement of marmots in that part of the world. So you've got limited habitat, restricted range, and this intrinsic rarity, dramatic landscape changes, and increased predation. And so it's sort of a perfect storm of circumstances that led to that decline. So in 1996, the recovery team, which oversees decisions on the Vancouver Island marmot, tried to reestablish marmots in historical habitat. They moved 6 marmots from logged habitat into a historical natural meadow at Mount McQuillan. 4 of the marmots remained at the release site, so that seemed positive. They excavated and occupied old burrows, so that was very positive as well. They hibernated as a group, so those 4 all climbed into the same hibernacula. But unfortunately, next spring, found that the group had died during that first hibernation. And there's quite extensive investigation in that, but we never really identified a specific cause. But I kind of think in hindsight, that particular burrow was probably inundated with meltwater in the spring. So you can imagine, like if you get a whole bunch of water accumulating in a burrow and those marmots are in torpor, it can be a fatal situation. And they've seen that in other marmot species like hoary marmots, that sort of event. So the recovery team was writing the recovery plan for the species around 2000. They had this inherently rare population, severely declining, and they had that failed management translocation. So what do? They concluded there is sufficient natural habitat on Vancouver Island to support the recovery goal of, but essentially what it amounts to is 3 mammal populations and a total of 400 to 600 marmots, wild marmots. However, there are few animals exist for reintroductions or other management activities, and it was very unlikely that this population would spontaneously rebound of its own accord. And therefore, captive breeding and reintroduction present the only chance of increasing populations within a reasonable period of time and minimizing the risk of species extinction. So they didn't have the funds to support a captive breeding and reintroduction program that, you know, and that was like the recovery team acts on behalf of the province of British Columbia, and people wouldn't give money towards a government initiative like that. So they established the Recovery Foundation, which is a charity, and they were to produce an entity responsible for coordinating and administering recovery actions, fund, facilitate, promote, and carry out activities necessary to assist and enhance the survival of the species, including the aforementioned captive breeding and reintroduction program. And I should say that, you know, we received some support from the provinces, you know, in corporations, but 70% of the support actually comes from the public, which to me says that marmots are important to people. So I think that that's really important, you know, to get that support. Oh, sure, sorry.
Didn't want to.
No, that's all right. Feel free to interrupt me. Okay. So, you know, very good public support over the years, which is really encouraging. So two-pronged approach, a zoo-based program. So the first thing, get the marmots into captivity in case something really catastrophic happens in the wild. Try to ensure as much genetic variety as possible is retained in that captive population. Try to figure out how to actually manage captive marmots and get them breeding. So, you know, husbandry techniques, plus there's also some research questions. And then at the end of the day, provide animals for reintroduction to the wild. So the Toronto Zoo was the first recipient of marmots back in 1997, and they're still in the program. The Calgary Zoo in 1998. And also from 2000 to 2014, there was actually a private venture, the Mountain View Conservation and Breeding Society, which also was part of the captive program. The second phase of the captive program was the construction of a dedicated facility at Mount Washington. So support all the initiatives of the zoo-based program, also provide the marmots with pre-release conditions so that they're, you know, better acclimated to wild conditions, and you simplify the logistics of actually getting those marmots out onto the landscape, and obviously be a breeding center as well. So that's the Tony Barrett Mount Washington Marmot Recovery Center, and it received its first marmots in 2001. And you see that red line there. Well, that's actually 16 feet in elevation. So you can sort of see how the building just gets buried in snow. And of all the things, over all the years, I've become very good at shoveling snow. So that's just, you know, like sometimes you get up in the morning, you open the front doors, and that's sort of the wall of snow that you're confronted with. So it's amazing how much snow you can actually move. Not this year though. There's almost no snow, right? Okay, so between 1997 and 2004, marmots were strategically captured for the captive program. So out of 55 wild captures, 31 of those were pups. What they were finding is that pup survival at that time was very low. And so, you know, the chance that you were able to ensure their survival much better by bringing them into captivity. At some of the colonies back in the late 1990s, like there was 0% survival of pups from one year to the next. So that was, you know, a large part of the captive program. We also captured marmots from that log habitat, knowing that these marmots would be there, and within even a single generation of those marmots, that colony would not exist. So we target those as well. And so during the whole course of capture efforts, we only captured one breeding age adult from the natural colony. So, the one thing that, people sort of look at it, and 55, was that driving the extinction itself? And it probably influenced that a bit, but, they were actually, there was a plan to it so that it wouldn't interfere too much with the wild population. Of course, when you start this kind of program, you have all sorts of questions about managing marmots. How do you get them to breed? What kind of diseases do you have to be concerned about? And I won't bore you with all the ins and outs of that, but I'll just sort of give you an example of the approach we took. So in terms of health management, we thought it was better to prevent disease rather than dealing with it after the fact. So the marmots are maintained in strict quarantine. Even if you go to the Calgary Zoo or the Toronto Zoo where they have marmots, they're not on public display. They're actually at facilities off-site. So we have strict biosecurity protocols. We distribute the marmots between those different facilities, provides more room for breeding, but also if you have a disease outbreak or something catastrophic, not all your eggs are in one basket. We have a very rigorous program of health evaluation and monitoring. So after bringing the marmots in 1997, everybody's looking over your shoulder. By 2000, we were actually able to start getting breeding of captive marmots. So that was really a turning point. This is really important. And I just like this picture. Like, we didn't actually arrange them all like that, but we have nest box cameras, and that's there's 5 pups in there. One of their heads is kind of buried, but yeah, I kind of like that picture. So a real turning point, breeding in 2000. And then by the time we got to 2003, as you can see, the captive numbers are starting to increase. They're not increasing because of wild captures, but because of successful breeding. The recovery program always felt that we don't want to leave marmots in captivity for too long. We want to try to get them back to support the wild population as efficiently as possible. So by the time we got to 2003, we decided that it was time to do an experimental release of captive marmots. So we've taken them from the wild. We've imposed these artificial conditions on them. Some of them have been born in captivity, never experienced wild conditions. And so how do we go about moving them back to the wild? So the top's in preparation for release. So the first thing is we identify those marmots that are suitable for release. How do we do that? Well, you don't have to see, this is our breeding matrix. So what we've got across the top, we've got all the females in captivity, and across the left-hand side, we've got the males. Those individuals in the upper left-hand corner are those individuals and pairings as well. If you look at the cells that have the lowest genetic representation. And these individuals have the highest genetic representation. And those are the individuals that we want to release back. We want the ones that are important genetically or poorly represented, we want to keep those as breeders to maintain a balance in our captive genetics. So as you can see, like, we've had captive marmots breed in 6 consecutive years. We've had captive marmots where they've lived in captivity to ripe old age, probably 12 or 13. They produce 1 offspring. So you can see that if you have a female producing 6 litters over, or more over the course of a lifetime, that one individual that this other females produce will essentially be swamped by all these genetics. So what we do is we try to equalize their genetic representation. So these individuals, which are well represented genetically, are the individuals that we identify for release to the wild. And that helps to equalize our genetics and our founder contributions. We quarantine the marmots at our Mount Washington facility. So the ones that are born there obviously have always been in quarantine, but the ones coming from Toronto and Calgary or Mountain View in the past would all go through a quarantine period. We're able to expose them to elevation, natural foods, natural weather conditions. They go through again an intensive health evaluation, sort of like the astronauts going out on into space. Like we make sure that they are healthy before they go to the wild. It's just a few examples. Marmot getting an EKG. We've got the ability to take radiographs. We've done extensive blood sampling and analysis on them as well. We visually mark them with metal ear tags. And that actually, believe it or not, if you have binoculars or a spotting scope, you can identify individuals as well. So if you ever see a marmot anywhere, that's one thing to look for is ear tags, because if it has ear tags, it's a known individual that we've had some association with. And then we surgically implant abdominal radio transmitters as well. So we have to use radio telemetry. Like you can imagine, you're in that landscape. So this is Strathcona Park, and you're looking for something about the size of a cat in there. Very difficult to locate them. So remember when I said hibernating species, like these guys, their weight changes so dramatically that there's no way we could put a collar on them, because either if we put it on at the wrong time, it'd slip off, or the alternative would be that, it would really start to erode the neck tissues. So it sounds dramatic, but this is actually something that's done on a number of different species, and including marmots of other species. I've actually done this in wolverines, mink, otters, all sorts of, and it's amazing how well tolerated it is. So they've got this radio transmitter, which is free floating within the abdominal cavity. Each of these radio transmitters has an individual frequency, so we can locate them through telemetry. It's temperature sensitive, so as the body temperature goes up, the pulse rate of the transmitters will go up. So this conserves battery life during hibernation. So right now, except during the warming periods that they have, is beating at a very slow pulse. So that saves our battery. And then during the summertime, if it goes down because it's the temperature, say there's a mortality, the pulse rate will go down because it's just beating at the ambient temperature. So that's how we're able to locate whether or not locate mortalities or identify marmots that have died out there. So we're all fired up. We've in 2003, we did our first release. It was to Green Mountain, which is a historical site, which has supported good numbers of marmots in the past. So 4 marmots went out there. 2 of them were captive born. 2 of them were wild born. One of them actually had originated from Green Mountain. And they did really well for the first 45 days. Then over the course of a day and a half, 3 of the 4 were killed by a cougar. And when our field technician was actually out there trapping that 4th individual to bring it back into captivity, there was a cougar sitting sort of in the bushes. So you've tried your first experimental release. Everybody's looking over your shoulder. What's, like, what do you do? Well, what choice do you have? You persevere, and you can't just have a sample size of 1 of anything. So persevere. And so our progress since 2003. So the next year, we released marmots, and we're actually able to observe those marmots, and they survived until hibernation. So get through their first summer. That was a victory. And then the following spring, they emerged. So they'd survived their first wild hibernation. And these were marmots that had never actually hibernated in the wild. So that's really encouraging. They survived and entered their second hibernation. And then, lo and behold, they survived their second hibernation. So spring of 2006, and lo and behold, we had our first captive marmot pair produce a litter at the Hagley Lake Ecological Reserve. So this is Haida and one of her 4 pups. So when you see that, all the losses and everything that sort of goes along with it, and it's like, gee, maybe this actually will work, which is really, it's really a roller coaster. So from 2003, when, I said we knew of 22 marmots, wild marmots, and, less than 30 is what we say, assuming we might have missed a few individuals. We had this sort of golden decade. So we continued to do reintroductions, and we were able to release 424 marmots from captivity. And by the time we got to 2013, we actually had an estimate, somewhere between 350, 375 wild marmots at 25 sites. So this is quite remarkable. And you can say, well, those are just the marmots that you're putting out to the wild, but we didn't see that. What we saw was enough of the captive release marmots surviving and reproducing and producing their offspring. And their offspring, so wild-born offspring, really seem to be a big part of that population. So like if you sort of do the extrapolation, that population is just going to go up and up, right? Well, theoretically. So what we did was we reduced the size of the captive population. We were told to, to curtail the number of releases going back to the wild and limit the use of the Mount Washington facility. So it's just, we bring the marmots from Toronto and Calgary, quarantine them. If we're moving marmots around, we bring them to the facility for a short period of time. And so it just would allow us to move them around a bit more effectively. Unfortunately, between 2013 and 2016, there's the realization that that was a bit premature to curtail everything. So we're told we need to build up the captive population again. So we actually captured 33 of the wild marmots out there, and they were often descendants of marmots that we'd originally released. And that was because our captive population was becoming more and more inbred and older because we really hadn't focused on the breeding. So this allowed us to bring some young individuals in with, genetics that weren't represented in our captive population. We returned the Mount Washington facility to year-round operation, including captive breeding, and increase releases to the wild. So the current status of the Vancouver Island marmot. So from that situation that we saw back in 2003, we've been able to increase the number of colonies and the number of individuals in the Nanaimo Lakes. We've been able to significantly increase the number of marmots at Mount Washington as well. And Mount Washington is actually a place where we're able to build up the numbers. They're good survival because of all the human activity, keeps the predators down. And so we actually use that as an opportunity to move marmots into Strathcona Park as well. So we've been able to build up the population in Strathcona Park, and it's actually, at one point, it appears to have been extirpated. It was a place that had marmots historically, but by the time about the early 1980s, there are no marmots there that we could determine. We also, the yellow star there, we've also introduced marmots successfully into the mountains on the Clayoquot Plateau as well. And we tried doing introductions up at Shone Lake, but it doesn't look like we're able to establish any numbers there. So from the 22 known wild marmots at 5 sites in 2003, we reached that high point in 2013 of an estimated 375 marmots at 25 sites. And the results of our past year, we're at about 303 wild marmots, but we got them at 33 sites. And some of those sites, we've actually seen sites that are not where we put the marmots. The marmots have actually established themselves. And for example, in Strathcona Park, we have hikers reporting observations of marmots. And so what's happening is that the marmot colonies are becoming established, and then they're sending out dispersers, and those dispersers are establishing themselves. So that's really quite gratifying. And I think, when you think about 5 sites compared to 33 sites, that gives you a lot of flexibility to manage the species. So yeah, just sort of a graphic representation of where we've come since 2003. The wild population is still small, and remains highly vulnerable to stochastic or random events. And I guess I always equate it like flying a plane, at 30 feet versus 3,000 feet. Like when you're only at 30 feet, it doesn't take much of a change in elevation to cause you to crash. And so you're trying to build up those numbers as much as you possibly can. I almost hate to even bring this up in a talk anymore, but COVID-19, I mean, we've all sort of lived under the threat of that. And the one thing that became very apparent, there's a huge taxonomic range of infectivity of this virus. So when you think about, humans are susceptible, but also primates. Who would have thought? So, felids are also susceptible as well. Mink showed a huge dramatic response to this, to the point where they're actually, doing large eradications of minks at mink farms. And they also found like Syrian hamsters and Paramiscus mouse also show clinical signs from COVID infection. So the question is, well, are Vancouver Island marmots susceptible? Like they're a rare species, their genetic variability is less. We don't know. But thank goodness we have that sort of protocols of biosecurity in place that hopefully safeguard them to some extent. But you're always looking over your shoulder with this, because the other thing is in the news, there's been avian influenza, which has shown a huge range of infectivity. So it's not just, bald eagles have certainly suffered in certain areas to that. But, like skunks and raccoons, foxes, they've all shown susceptibility. So there's always that next threat coming around the corner. Elephant in the room, climate change. How will that affect not just ourselves, but also the marmots as well? We certainly saw an impact back in 2015 with, the heat domes, atmospheric rivers. These things are terms we never really had, 10 years ago. And we had good numbers from 2023. But now the snowpack is 40% less than average. So what does that mean for for this upcoming season? We don't know. I guess we're kind of like farmers. We're never really happy with the conditions we're dealt, but these are the sorts of things that you're always kind of worried about. And then predation as well. Another one of those stochastic events that we have to think about. And it continues to represent the biggest threat to marmot populations and their recovery. And if you look at over the last 10 years, 85% of our predations, our marmot mortalities from predation have been from cougars. So are we in a predator pit? So, situation is created when a prey population has been reduced for various reasons, and pressure from existing predators reduce numbers even further or inhibit the regrowth of the prey population. So, that's something we have to consider. Like even though the numbers look pretty promising, we have still very small colonies. It doesn't take much an event like a predation event to disrupt that colony. If you lose your adult breeding female, that can cause it to go into a tailspin. So numbers are still really small and susceptible to all these different things. A hot summer, it could be that the food plants available for the marmots dry up sooner. They're not able to put on the fat reserves, which may affect hibernation survival or the reproduction the following year. I guess the question is, how do we know that it's cougar predation and not scavenging? Well, what we see is this dip in survival in late through August and early September. It happens every year. And the thinking is that the cougars actually follow the ungulates, so elk and black-tailed deer, up to higher elevations. And it just happens that the marmots are also up there as well. So, they also, people throw out the term hors d'oeuvre, and I guess that's sort of what it represents. But, certainly we will see that. And so we have maybe a good year of survival in the wilds during the winter time, good reproduction, but you always know the other shoe is going to drop in August and September. So we see that every year. And then the other clue is the fact that the cougars, when they predate marmot, they will discard the gastrointestinal tract. And almost invariably, that gastrointestinal tract, like that circle is around the stomach. And so, these marmots are not sick marmots that the cougars are getting. These are marmots that are above ground actively feeding. And it's funny because, like a marmot's the size of a house cat. And during the summer when they're eating, this is no exaggeration, their stomachs can be the size of a grapefruit. That's how much food they're taking in. So they have to wander around and yeah, it just the cougars certainly are an influence right now. How do we define success? Well, used to be 3 geographically distinct wild metapopulations of 150 to 200 marmots. However, as we found, there's no time component to that. So even if we achieved those numbers for 15 minutes, we were considered to be finished and successful. But what we've done is actually incorporated more of a modeling exercise. And so our new recovery goal, which we worked in collaboration with the IUCN to develop, is the existence of 2 geographically distinct wild metapopulations having a greater than 90% probability of persisting for over 100 years without augmentation from the CAFI program. So that's quite a mouthful, but what it does is it just incorporates population trends, survival, all these different components, and gives us an idea of, well, what is the population likely to do over time with these sort of parameters. It's not perfect, and we're still trying to figure out how to actually get a good working model and incorporating appropriate data to inform us. So it's still, as I said, a work in progress. But we'll continue with captive breeding and reintroduction. So in this year, 2024, we actually have 60 marmots that are up at our Mount Washington facility hibernating as I speak, which will be ready for release to the wild. We'll continue with inventory and monitoring as well of the marmots. So not just going out with binoculars and looking for marmots at select sites, but also doing the radio telemetry. We've also found that inventory is really facilitated by using trail cameras as well. Some of these sites you can strategically put your trail camera by a burrow and get an idea if there's pups there, how many individuals are there. So that's been quite effective. In the spring, in order to enhance survival, potentially enhance reproduction, we also provide supplemental food. And so these are actually primate leaf eater biscuits. And they don't even if they get wet, they don't disintegrate or anything like that. And the marmots just love them. So it provides sort of that added nutritional source. Maybe if it's a bad winter where there's not a lot of early melt and good food. So yeah, they don't taste that good as far as I'm concerned, but the marmots love them. We'll continue with habitat management. It's kind of a funny thing, but obviously logged habitat influence the marmots. But what we're seeing now, as conditions warm, some of these subalpine meadows are actually experiencing a lot of tree ingrowth. And so at some of the sites, we're actually we go out in the fall and just remove some of that, and it probably shrinks the habitat. But it also, at some of our best sites, these trees are getting to the point where cougars can get really close to the marmots, and so we try to manage that as best we can. And of course, ongoing research and data analysis will be something we'll be actively engaged in the future. So hopefully, that's what we really like to see, the pups for sure. Hopefully we can build in enough resiliency in the wild population and get to that point where there's sufficient sustainability. And like I said, it's a work in progress, but certainly if these measures hadn't been taken, almost certainly the species would be extinct. And so the question is, what's the value of Vancouver Island marmot or population of Vancouver Island marmots? We're asked that repeatedly. Greater sage grouse, what are they worth? Oregon spotted frogs, loggerhead shrikes, mountain caribou, the southern resident killer whales, the Banff Springs snail. And I guess, it's hard because people say, well, what difference does it make? And that's a hard one to answer sometimes. But I always like, so Ken Armitage, he did write the book on marmot biology. He's passed away now, but he started working on yellow-bellied marmots back in 1962. And I just like this quote. He said, "People often ask me, what are marmots good for?" And I ask them, what are you good for? So, what do you call a group of marmots? A madness. And so hopefully, looking at all this, I mean, everybody has their opinion. So if you think it's madness, well, that's totally fine. But I I, I think that's kind of a funny term. But yeah,
Yes, continue.
let the madness continue. There you go. And yeah, like a large part of our observations now, particularly in Strathcona Park, come from the public. And so, yeah, if you think you've seen a marmot, then by all means, report it to us on our website. And it's funny because of the fact that, yeah, we see them in these subalpine meadows, but over the years, we had a Vancouver marmot turn up at Banfield. We had one turn up off Jingle Pot Road in Nanaimo there. We had one turn up at Whiskey Creek. And I'm not sure if you guys are following it or not, but one of the marmots we released at Green Mountain ended up making his way to Arrington. So he's running around Arrington, and we actually had people call us and say, there's a marmot in my backyard. And we actually cornered him under a culvert under a road. And, so we had a trap at one end. And what I did was I climbed into the culvert and just sort of did like the commando walk through the mud and the spiders and all that. And we're able to herd him back into a trap. We brought him to our facility, gave him a girlfriend, and then moved him out to Strathcona Park. So, expect the unexpected. The other thing I'll just say is we also see yellow-bellied marmots turning up here, and they do represent, potentially a threat to the Vancouver Island marmot. So, yeah, if you see we've had them in Victoria, we've had several in Nanaimo here turning up, and they come under vehicle hoods. Sometimes they come in loads of firewood. Sometimes they come in construction materials as well. So thank you. And I really appreciate your attention. And yeah, if there's any questions.